A quick word about myself. I have more than 30 years of experience in industry, mostly in the electrical industry. I work with Siemens in India, Germany, and the UAE until recently. I work with Schneider Electric in the UAE and in Canada. I work with Mola Electric, and I used to work with Emerson Electric in India as country head for 2 of the divisions. I love studying, so I am a PEng, a professional engineer from Canada. Besides, I also have my MBA and my CMA designations. Hobbies, I teach. I teach as a guest faculty, but I don't teach electrical engineering. That's where it's a hobby, so it's not exactly what I do for business. I teach the MBA students. So what do we exactly do when we do power system analysis? Actually, what we do is we, okay, well, thanks. Where do I name this? What we do is we actually model electrical networks, and this is the softwares that we use, and we can do different kind of studies using the modeled electrical networks. So we can start out, the basic studies that we do is short circuit study, which is basic to determine the maximum fault currents. Then we do the load study and the relay coordination studies. Now these 3 studies, the short circuit study, the relay coordination study, and the load flow studies are the basic studies which are used for most networks, either in the beginning of a project, or it can also be in between when customers have organically grown their loads in their generation and they need to have a relook at their systems. Besides, we also have other additional studies like the motor starting study and the harmonic study. Now, of course, these studies are all conducted under the realm of standards, obviously. So how do you measure? You measure using standards. It could be IEC standards, it could be American national standards, it could also be, if you're looking at offshore and shipbuilding kind of stuff, then you're looking at DNV. When you look at the bottom slide, the bottom half of the slide, the engineering services to meet requirements of standard authority, what happens is that as you start to do these studies, that the load studies, the short circuit studies, etc., you start to get more holistic, and that's where the bottom studies, the reliability studies, the electrical hazard and operation studies, the FMEA studies, and all these things start to happen with customers. So you get more and more holistic in the sense that you're always looking at hope for the best and plan for the worst. So that's what it's all about with the respect to the electrical networks. One of the questions that I really needed to answer when I was preparing my slides for this session is, okay, Dinesh, so we do power system analysis. How exactly does it come down to sustainability? And this is a slide I made. For example, we reduce the maximum demand. When we do our load studies on the system, we see how we can reduce the maximum demands, for example, sequential starting of motors, etc. We also reduce downtime because we do our coordination studies, and we make sure that if there is a fault, that's restricted to as local network as possible, doesn't go through to the other networks. So for example, if it's in your house, you might see your one appliance that's gone into a short circuit, only that particular room might be out of power, but not your whole house. And that's the concept here. And of course, we also reduce heating, which is a waste of energy. That's by doing our harmonic studies. All this results in reduced capex. Generator sizing is reduced. That's reduced capex. That is capital expenses. And also reduce OPEX, because power consumption is reduced, so your operating costs are also reduced. All this leads to reduced carbon footprint and improving sustainability. I hope this makes sense to all of you. Our studies are conducted wherever there is electrical power, which is almost everywhere. So generation, where it's generated, it's transmitted to the distribution center, and of course in verticals, industry, transportation, low voltage. But of course, mission critical verticals are more sensitive to such sustainability studies. They are more usage of power, so obviously every percentage point adds up to much more. And then that's where I would say the verticals like process, that's oil and gas. Large industries is another important vertical for us, which is infrastructure, manufacturing, pharma, food, marine, and of course IT, which is data centers. They're power hoggers. So every 1 percentage point that we make a difference is going to make substantial differences. For example, a refinery is around 10 megawatts, which means around $500,000 of power almost every day. It's millions of dollars in the year. So even if we effect a 1% saving there, it's huge.